Hi guys, this is the lesson for multiple angles identity, and when we say multiple, that means there is a multiplication. As you see, angle U is multiplied by 2. That's why we call these multiple angle identities. So for sine of 2U, and the double angles are the most important ones. They are like a subset of multiple angles. Sine of 2U equals 2 multiplied by sine U cosine U. Cosine of 2u is a little bit more of, I would say, not complicated, but diverse because it has different forms. So there are two forms. The highlighted ones, you could use any of these. What I had here is I just explained how you can get from this to that. You can either I would say not memorize it, but the reason why we have 2 because we can substitute cosine squared by 1 minus sine squared, and that way you get 1 minus 2 sine squared of u, and you can use either or. And a third one could be obtained by substituting the sine squared with 1 minus cosine squared, and that way you get cosine squared minus 1 because you distribute the negative plus cosine squared, and that's 2 cosine squared minus 1. If you ask which one should I use, all it depends on the question itself. We'll see in the problems later on. For tan of 2u equals 2 tan u over 1 minus tan squared. And what I did here is I put it as a sum. So I went back to the sum identity, u plus u. So if you go back to the sum identity, you can see how you can get this identity, which is 2 tan u over 1 minus tan squared. Reducing or half angles, sine squared of u equals 1 minus cosine 2u over 2. And the reason why we say reducing power, half angle, because u is half of 2u. Okay, again, cosine squared, 1 plus cosine of 2u over 2. Tan squared, 1 minus cosine of 2u over 1 plus cosine of 2u. What I put in parentheses is how you can obtain that. Take 33b and put sine squared by itself. You can try it just to understand how I got this. Take 33c and put cosine squared by itself. So solve for a variable. That's what I meant. So if you take 33b and put sine squared by itself, which means subtract 1 on each side, divide by negative 2, you obtain that. And if you take 33c and you try to put cosine squared by itself, so you basically add a 1 on each side and divide by 2, then you will get what we got here in 36. So those are the new identities we're working with. Example 1. Solve sine of 2u equals cosine. And when we say solve, that means we need a solution. Solutions are answers, and answers are angles in trig. So what we do is we apply the double identity, and I always put which number I'm using, which identity, 32. Identity 32, you can go back up for identity 32. Right here, 32 is 2 sine u cosine u. So I'm gonna substitute sine of 2u or 2x, I'm sorry, any variable, 2 sine x cosine x equals cosine x. I cannot cross these. I cannot divide by cosine x. We cannot divide by a variable. A variable could be a 0. What we could do is equal one side to 0, factor, and solve. And that's what we're going to do. Subtract cosine and x on each side. And we mentioned that at the very beginning of the trig unit. I cannot cancel cosine minus cosine. Why? Because this cosine is attached to a block. It cannot go away from it. So I cannot just subtract those two. I can factor by. And some students found this confusing last year. Some students liked it. If you substitute by using just one letter, instead of sine, put s, instead of cosine, put c, just so you can see the common factor. If you don't like it, just keep it sine x, cosine x. So 2sc minus c, the common factor is c. So factor out c, and you get 2s minus 1, or 2 sine minus 1. So cosine x equals 0. 2 sine x minus 1 equals 0. The angles that have cosine equals 0 using the unit circle are pi over 2 and 3 pi over 2. And add a 1 on each side divided by 2. The angles that have sine x equals half are pi over 6 and 5 pi over 6. So again, the golden rule, when we solve, we set the equation equal to 0, factor, and solve. And we are solving in the interval 0, comma 2 pi, which means the whole circle with no repetition. You don't go, let's say you have the answer, as you see right here. I think it's in the next problem. But let's say the answer was x equals 0, angle 0. You can't say angle 0 and angle 2 pi because 2 pi will be outside the interval you're solving. Let's see right here, the second example. So again, golden rule, we are going to equal the equation to 0, factor, and solve. I think right here, I'm sorry, it meant to be here plus 2 sine x, not plus sine, okay? So I think I missed the 2, I'm sorry. So plus 2 sine plus 2 sine, so I get sine squared plus 1 plus 2 sine x equals 0. So part of the golden rule, equal the equation to 0. What I did here is called substitution. So I substituted sine with t just to make it simple to see. So, or s, or whatever letter you want to use. Sine squared t squared. 1, I put it right here, and 2 sine 2t. That way I can see that special case, which is t plus 1 parentheses squared. So sine plus 1 squared equal to 0. That means sine plus 1 equal to 0 if you square root both sides. And sine x equals -1, and the angle that has sine equal -1 is 3 pi over 2. Again, this is a special case. If you didn't see it, you can use X method, but as we talked in class, you definitely need those special cases before you move on to a next math class. Okay, and this is the special case. I see it right here, so I factor it out. And those are the 2 examples I gave you. You guys are supposed to do the practice problems. And after you do them, I'll post the key for those 1 through 10, page 432. And I hope this helps. Please text me if you have any questions.